Hello children, we already discussed one method to find whether the given number is a perfect square or not. What is the name of the method? The repeated subtraction method. And one more method is there, prime factorization method. Okay, so the next method is prime factorization method. So we cannot apply the repeated subtraction method all the time. Can you say why? If the numbers are very large, if you apply the repeated subtraction method, it will be time consuming and laborious. So we are not using that method. So practically we use the next method, and the name of the method is prime factorization method. Now what is meant by prime factorization? We have already learned, if a number is given, we can find out the prime factors of that number, right? Which are the prime factors or which are the prime numbers? The prime numbers are 2, 3, 5, 7, 11, etc. These are the prime numbers, and we have to start dividing the given number with these prime numbers, suitable prime numbers, and finally we will get the factors of that number, right? Now for example, consider the number 32. We have to find out the prime factors of this number. Then how will you start? 32, then I will write like this, division method. We are applying the division method now to get the prime factors. Then 32 is an even number, so we can start with the even prime number 2. Then it is a 16, again with the 2, 8, 2 8s are 16, again with the 2, 2 4s are 8, again with the 2, then 2 times, again with the 2, here we have 1. Therefore 32 we can write as 2 into 2 into 2 into 2. Okay. So when we multiply all the prime factors, we will get the given number 32. And this method is known as prime factorization method. Now look at that. I have already, that means here the number 40 is given. The prime factors by prime factorization method, the factors are 2, 2, 2 and 5. 2 into 2 into 2 into 5. Then 36, we can start with the 2, then 18, again 2, 9. Then with the 3, 3 3s are 9, with the 3, 1. Therefore 2 into 2 into 3 into 3. Then 126, we can start with the 2, 2 6 are 12, then 2 3s are 6, with the 3 it will be 21, with the 3 7, and again with the 7 it is 1. So 126 equal to 2 into 3 into 3 into 7. Okay, we have already learned. Now we can apply this method in order to check whether the given number is a perfect square or not. Now what we have to do is express the given number as a product of prime factors. That is the first step. Express the given number as a product of prime factors. Now here the number is given as 81. So you want to check whether 81 is a perfect square. Then 81 you have to factorize. 81 equal to, then 81, we can start with which prime number? 3. Okay, then 3 2s are 6, then 27 will come there, again with the 3 9s are 27, then with the 3 3s are 9, again with the 3, then 1. Okay. Now first step, express the given number as product of prime factors. So 81 we can write as 3 into 3 into 3 into 3. Now look at next step, group the prime factors. You have to group the prime factors into pairs of equal numbers. Pairs of equal numbers or pairs of equal factors. That is the second step. Group the prime factors into pairs of equal factors. So we want to group these prime factors, okay, into pairs. So, the first pair 3 into 3, in one pair we have two numbers and equal numbers. You have to take equal numbers. So, 3 and 3 in one pair. So, the next pair is 3 into 3. Okay. And if we can group these prime factors into pairs of equal numbers, we can say that 81 is a perfect square number. Okay. So, if we can group the numbers into pairs of equal numbers and if the grouping is complete, we can say that the given number is a perfect square. So, we can say that 81 can be expressed as product of pairs of equal factors, product of pairs of equal factors. Therefore, 81 is a perfect square. Therefore, 81 is a perfect square. Okay. So, there are two steps. First step, you have to express the given number as the product of prime factors. Second step, you have to group it pairs of equal factors, and if the grouping is complete, it will be a perfect square, otherwise it is not a perfect square. Now, we will consider the next example. 1296. You have to check whether it is a perfect square. Now, we have to do the prime factorization. 1296 2. 1296 is an even number. So, we can start with the even prime number 2. 2 6 are 12, then 2 4s are 8, then 648. If you are not getting the quotient, do the division separately. Then 2 3s are 6, 2 2s are 4, 2 4s are 8, again with the 2, again with the 2, 81, then 81 we can do with the 3, 27, then 3, 9, again 3, then 3, 1. Then therefore, 1296 equal to, write down all the factors, 2 into 2 into 2 into 2, then 3 is repeated 4 times, so 3 into 3 into 3. Then what is the next step? We want to pair it, pairs of equal numbers. Then 2 and 2 in one group, next one. Now look at that, the pairing is complete. So what we can say that 1296 is a perfect square. So how can you write? We can write as 1296 can be expressed as pairs of equal factors. Therefore, 1296 is a perfect square. 1296 is a perfect square. Now next 450. Now 450. So we can start with which prime number? 5. Then 5, 5 9 45, 0. Then again we can do with the 3, 30. Then with the 3, 10. Then we can do with the 2, 2 5s are 10. Again the 5, 1. Therefore, 450 we can write as, so we can write down the equal numbers together. So 5 comes 2 times, so 5 into 5. Then next 3 we can write 3 into 3 into 2. Then we want to pair it, pairs of equal numbers. 5 into 5, one group, then 3 into 3. What about 2? 2 is left, unpaired. Okay, 2 is left, here 2 is left unpaired. Then, can we say that 450 is a perfect square? No. 450 is not a perfect square. So, we can say that 450 cannot be expressed as the product of pairs of equal factors. Okay. Therefore, 450 is not a perfect square. Now, next one, 6561. 6561. Using which number we can start the division? You can apply the divisibility test. Okay. We cannot start with a 2. Then can we start with 3? Look at that, 1 plus 6, 7, 7 plus 5, 12, 12 plus 6 equal to 18. So, we can start with the 3. So, 3 2s are 6, 1 time, then 26, 24, then again we can do with the 3. 3 7s are 21, then 3 2s are 6, 729. Again with the 3, 3 2s are 6, 4, then 3. Then 243 we can do with the 3, 3 8s are 24, 81. Then with the 3, 27, again with the 3, 9, again with the 3, 3, then 3, 1. Therefore, 6561 equal to 1, 2, 3, 4, 5, 6, 7, 8 3s are there. 1, 2, 3, 4, 5, 6, 7, 8. 8 3s are there. Now, we have to group it pairs of equal factors. Here all the numbers are same. Therefore, 3 into 3, one group, again 3 into 3, 3 into 3. Now, the pairing is complete. So, what we can say that 6561 is a perfect square. Okay. On factorization, we got the factors and we can express it as the pairs of equal factors, and so we can say that 6561 is a perfect square. Therefore, 6561 is a perfect square. Now, we will look into one more number, 11,250. 11,250. So, we can start with a which prime number? 5. Okay. Then 5, 5 2s are 10. Again 12 we will get 5 2s are 10. 25, 0, then 5, 5 4s are 20, 450, again with the 5, 90, then 3, 30, then 3, 10, then with the 2, 5, then 5, it is 1. Now, we can write down the factors. 11,250 is equal to, all the 5s we can write together, 1, 2, 3, 4, 5. 5 into 5 into 5 into 5, then into 2 3s are there, 3 into 3 and only 1 2. Now, after writing the prime factors, you have to group it, 5 into 5, one group, next equal numbers, then 3 into 3. Now, what about 2? 2 is left unpaired. So, what we can say that 11,250 is not a perfect square number. And what is the reason? Here the prime factor 2 is left unpaired, and therefore 11,250 is not a perfect square. It's not a perfect square. Now 2 questions as homework. Check whether the following numbers are perfect squares or not. 10,584 and the second question is 289. That's all for today's class. Thank you.